webinar series. My name is Reinhard Scholl from the ITU, the International Telecommunication Union, and it is my pleasure to facilitate today's session on AI empowering industry potential. ITU is the United Nations Specialized Agency for Information and Communication Technologies. ITU allocates frequencies to the services that make use of the radio communication spectrum. ITU develops standards, and ITU assists developing countries in setting up their information and communication infrastructure. ITU is also the organizer of AI for Good in partnership with 38 UN sister agencies and co-convened by Switzerland. AI for Good is always online all year round, and it is a platform to explore how AI can help achieve the Sustainable Development Goals. Today's webinar is the first in a series of 4 episodes that have been curated by a steering committee comprising Wang Xiyu, the Executive Vice President, Chief Technology Officer, and Chief Information Officer of ZTE, Dr. Gao Wen, the Director of Pengchen Laboratory and one of today's speakers, and Ibrahim Haddad, the Executive Director of the Linux AI and Data Foundation. As usual, we count on your support to make this webinar an exciting experience. Please use the Q&A functionality at the bottom to write questions for the speakers and use the chat functionality for general comments. Please make sure that you set the chat message recipients to all panelists and attendees, and not just to all panelists. In today's program, we will feature 3 talks. The first presentation will be given by Dr. Gao Wen, followed by Mr. Wang Xinhui, the Head of Wireless Standardization and the Vice President of ZTE, and Dr. Feng Zhenlan, Chief Scientist of China Mobile Research Institute. So it is my great pleasure now to welcome Dr. Gao, the Director of Pengchen Laboratory. Dr. Gao has been engaged for a long time in research. His research focuses on computer vision, on pattern recognition, image processing, multimedia data compression, multimodal interfaces, and virtual reality. So Dr. Gao, I don't know whether you follow your Google Scholar, your H-index, but I looked at it just now, and your H-index is 100, exactly 100, with close to 50,000 citations. So that's really very impressive. Congratulations.
Thank you.
Dr. Gao was also elected as an IEEE Fellow in 2009, then as an academician of the Chinese Academy of Engineering in 2011, and also an ACM Fellow in 2013. ACM is also one of our partners of the AI for Good. And you also served as a director of the Institute of Computing Technology of the Chinese Academy of Sciences, as executive vice president of the Graduate School of the Chinese Academy of Sciences, as a vice president of the University of Science and Technology of China, and as a professor at the School of Information Science and Technology of Beijing University. So it's fabulous to have you here, and very happy to hand over the floor to you now.
Thank you. Thank you, Chair. Thank you for the introduction. Let me share my screen. Share. Yeah, okay.
Okay, all right, perfect. Can you go on full screen mode? Yeah.
Yeah.
Okay, perfect. Great.
Okay. So hi everyone. Today I want to share some idea we are doing for AI for Good. So basically, what we are doing at AI for Good, we think probably we can provide some computing power, can provide some data, enough data, and it can provide some model for AI community. So for this three, we think probably the computer power should be good enough for take the task of pre-training on large scale model, and the data should be big enough for training a good model. Of course, the data should be protected. Then the model should be in open source, which can be easily being used for AI ecosystem. So that's basic idea what we are doing. So for this idea today, I want to share with you about computing power, about the data security, how we can handle data security, and how we can support the AI ecosystem. So this three topic is I want to share with you today. So go to the first, the big computing power. For this, actually, we have machine. We call that Pengcheng Cloud Brain. The short term is PCB. Is very easy to remember, PCB2, because we already have PCB1. So PCB2 is AI-oriented, machine special for pre-training, which is big machine. Actually, is a cluster, quite big cluster. So this cluster has been built up last year, which we can support the big model training. So about this machine, basically, PCB2 is a special design for AI. So the computer power is 1 extra operation per second. So the latency is only 2 microseconds, and also with a big storage system. So the storage is about 60p. So it's a cluster machine. So this machine actually with totally is 2048 CPU and 4096. You can think that GPU actually is NPU. So this is the computing power we use. So for this machine can efficient for AI training. Basically, it is just not the normal cluster. It's a very tight connection with optical network, which can link all the nodes together in very low delay, low latency. So this is the network for making more tight connection between the computing nodes. And for make this equipment, can communicate in high speed and wide bandwidth. We also have some special design on bandwidth. So the bandwidth also is very high, is wide, and which can support a very low delay. And the software, this equipment actually, we have a very good software which equipped for all the hardware can be used efficient. In the bottom is a hardware management system. Then in the middle is AI cluster software and AI platform. So in the up is it's a cloud brain application platform which can support different application oriented to either natural language processing or computer vision or some other applications. So this is the upper layer. So this machine actually has been tested. We join some computation. Every year there are 2 times computation for supercomputer. So we get 2 times number 1, the top score in the category of IO 500. So we are the most IO fast machine in the world. So which can count in all 4,000 nodes or even 10 nodes. All this score we get the first. And also we attend some AI performance testing, which also get the top score. So this actually the capability support we can make a very good pre-training model for AI. So this is another testing which you may know that is a machine learning performance testing. So our machine is in the computer vision task, which equivalent to NVIDIA A100, and for another task is for natural language processing. We are better than NVIDIA either A100 or V100. And with this machine, actually, we can support different large model training. Actually, we have done 5 models. Some model already finished, some model ongoing, but the small size of the model already done. So that 5 actually here is we call that Pengcheng Pangu big model, which is for natural language processing. And we also have the model for computer vision, model for multi-language translation, and for graph network computing, and for multi-model computing. So basically, we done in 5 different models. So each model actually we have with some model innovation or the implementation innovation, try to make the system more optimized, which can either in engineering level or in algorithm level. So with this, actually we can compare the result is better than some other model or system. So actually right now we have open 200 billion scale Chinese pre-training model, which all is complete open source. So this model has been tested by different tasks. Here is the list of tasks. If you check the task, all the red score is top score in the line. So which can you can make sure that the model maybe is the most better model compared with other model. And we also use multiple language machine translation task, which basically we have Chinese English database. Then some we call that small language. Maybe the corporate database is not that large enough, so we use bridge language. Use English as a bridge language. Then we can deal with some other small, we call that a small language translation. So this task also done quite good in this stage. And so the another many to many, actually this multi language translation system, we can support them many to many multilingual process. And also for computer vision, we have a model we call that 大圣, is a vision and cross modality model which can support either computer vision or maybe join all the input, from image, video, maybe speech, and so on. So which make the cross modality. So this model is ongoing, also show quite good performance in some tasks. So this is the first item I want to share. The second about the data. So for make the data available for the machine for the model training, how we can deal with enough data and how we can keep the data in its province. So this is actually a balance. So if you want to get more data, then maybe you will have the risk, the data province may be not keep in good shape, and or if you want to take the protection on keep the data, then maybe your data may be not rich enough. So how you can make the balance on that? Of course, if you can find a way to protect the data good enough, then you can use more data to make a good model. So how we can make that happen? Basically, if you look at the data may be owned by different owner. Some owner don't want to lose the right of data. So if you can show them you can protect their data, the data province in good enough protection, then maybe they can they allow you to use that. So then actually our way is we define a DPI, data programming interface. So all the data we divided that can between the model and the data, we use an interface, DPI. Then for the model processing, part, which can, through this interface, can use the data for model training. Then after training, there's an API application, where the API can, can use the model to make some different applications. So in this way, we core idea we provide is data don't move and model moves. So data will keep in the bottom, and all the application will touch any data. So they can only touch the model, but the model can touch data with our protection mechanism. So how we can share the value, not to share the data. So this is the key idea we are doing in our our system. So our system actually, if we think there's a data may be owned by either government transportation institution, or maybe medical hospital, or maybe police, or maybe financial institution, and so on. So this is a data owner. Then where the DPI may be a computing platform can touch data. So of course, basically, if you can get full data touched, then you can get good result. Of course, the good data shouldn't touch by the user or end user. So we divide the data use a running sandbox. So then we have the gatekeeper. The gatekeeper will keep the end user not touch data, keep that not touch data. Then there is a work branch, the work bench actually, which can handle to divide the data and the platform. Then there's a declaration. So if the program said I'm done, so I want to move the parameter out to the up. Then after the declaration, then the system will check that's the data, that's the is the parameter or some data in hand. So this check is very important. So we call that which can be used in different layer. So basically, our system will be, there's the data trust model. So different data owned by different owner, which can link to the trust model. Then the trust model will protect the data not touched directly by the end user. So basically, that's the idea. So we have the mechanism make that can do the data in very safe. The third part I want to share is about the AI ecosystem we support by the open source method. So we have done, we call that OpenAI community. OpenAI actually is a platform, totally a software platform or open source hub, which can support all the different source which you can share to the user. So basically, we have marketplace. We also have some very good store, good store. So basically, we handle the OpenAI for the open source community, which can share the software model or even open data by the community. Of course, for this, make this more doable, we also have the standard, we have the open source. So we have the organization to do open source, also to do some IPR standard and even finance. We also have the committee working on different fields like the education, fintech, medical, and transportation, and so on. So for make the general the organization more general, in structure. So we have the organization organized. Like in the middle is the OpenAI. Then left side, we have different membership. And right side, we have the either IPR or project management and so on. So this is somehow like the community operation. So for the community, we have the mechanism which can make the partnership, cooperate each other. We also have the university campus event. We also have the industry event, which we have many partnerships join with, and we also have the AI computation or exhibition or the development conference every year and so on. So this is the structure we have done. So this is here is the compact university campus workshop, which university student or young faculty join together to discuss how to share the open source software, how to share the model and so on. So we have done that in many different universities. For example, the 9 top university in China, each conference may be some 100 members join with, and we also have the OpenAI assembly, which community collaboration each other, which this is industry-oriented activity. So some company like Huawei, they host the assembly, So then we provide the computer power, a developer from university or from small company join with. Then every year we will have 2 or 3 times development campaign. So which the young generation come together to show their capability, contribute to open software. So I think the result is pretty good. So with this, the support, the community working larger and larger. So the ecosystem already support the open AI open source activity in China very good. So here is some more exhibition. We have some global AI Explore, which featured some enterprise or some open source innovation. So we invited many famous university professor or some CTO from industry to share their idea or their resource to all the open source developer. So which in China have make many people to follow. So right now there are already 800 some 100 million times 800 million times people will click the news, follow the news and so on. So in year 2019 and 2020, so we have 2 times AI computation. So the computation, many teams join the computation. So each time is, there are different tasks. So totally, every time there are more than 10,000 people join with the computation. So they provide some their contribution. So maybe that's over 40,000 times contribution and so on. So we also have the software OS innovation computation, so which the open source, they do some open source computation. They contribute to what they did. Then we will, give an award to the top score team or top score, person. And also we have a quite different, activity on AI open source community, from maybe 3 years ago. So every year we have sometime maybe 6, maybe 7, maybe 9 times different activity. So right now the open source code, a team can put that in the either a GitHub, or we also provide the OpenEye, the open source hub. They can put the source over there, so which can share by other community member. So environment already done. So the environment encoding algorithm, open algorithm, open data, and some open model. So here there are, for example, as I mentioned in the first part, the Pangu and Wudao. There are 2 models already open source, which can get the total model from the open source hub. So as a summary, for provide the compute power, data, and the model for AI for good, we already done enough computing power. We provide some data security mechanism and the system. We also support some open source ecosystem for AI. So this is what we are done today for AI for good. So if you have any question, I'm happy to answer. Thank you.
Thank you, Dr. Gao. That was most interesting presentation. Last year, OpenAI published its paper on GPT-3, the language model, and they received a lot of attention. Can you give us a feeling for the computing power that is necessary to run this model, and how much time would your machine need to run that?
Yeah, very good question. So, for example, for PCB2 run GPT-3 model, maybe it will take about 30 days.
Okay. On your machine?
In our machine, yes.
Okay. Okay. How much would GPT-4 need?
Oh, our team not do that yet, but we guess probably yet need sometimes complex than GPT-3, maybe 10 times complex.
Okay. So question from one of our attendees, does your lab, the Pengcheng lab marketplace share the AI model? Is it free for the user?
Yes. Yes, the model is all open source, is free to share. Yes.
Okay, good. Another question is how can the users trust the data platform to store the data? And what difference is between this platform and the privacy preservation machine learning, privacy preserving methods?
Yeah, well, actually, right now the system is developed by our engineer. So we use inside, not to open the system to outside. So we can only, convince our, partner, they own the data to make sure their data will keep in, good protected, not get by other. Actually, there are some algorithm called federation learning and so on. Actually, they support they can do that. But even with that idea, the data owners still think the system said that's okay, but they are not making sure by themselves they can totally trust the system, the data not public. So our system actually we gave some stage which the data owner can look at what happened on their data, so they can check every time if some user or some part they want to move the parameter, actually the model out, then the system will check all the data, everything inside, which either have their data or not. Then after that, they can see, okay, I'm sure my data is not, get by others. Then they can give the okay. Then the process will go on. Others, the process will stop there.
Okay. You mentioned the competition. So at ITU, we also run a competition. We call it the AI Machine Learning in 5G competition.
Mm-hmm.
We have a number of problem statements. And then, for example, we have also problem statement from China Mobile, ZTE, American, Russian, other universities and companies. And then participants have about 2 to 3 months to work on these problems. Now, your challenge is that like a 1 day, 2-day challenge, or does it extend over a certain period of time?
Yeah, it's a very good question. Actually, because the team member joined the competition in the beginning is very large. Yes, 3,000-4,000 team joined. So we are doing in 3 different stages. First, we deal with all the team. Then the second, we select only 100 teams going to the second stage. Then in the last stage is only 10 teams. So by that third stage, so for first stage is online. So it not take 1 day, 2 day. It'll take maybe some weeks. And the second stage is take 1 week, because the second also is online, but we take 1 week. The third is on-site, computation. So team will come to our side. We use the real machine. We will give some. There are some terminal which can link to PCB2. Then that's a 2 day.
When I saw your slide that you said it involved 13 countries and regions. So is the competition open also to participants outside of China?
Yes.
Okay, so it's
open.
Okay, very good. And then I think we addressed here one question, right, on participation. Okay, I think we have addressed these questions regarding the challenge. When is the next challenge? 2021, is that taking place already?
Yeah, I think it's ongoing. I think the task already announced, but the real competition not started yet. It should be this month or next month, but the third stage is in December.
Okay, good. Last question from my side. What would be your dream research project? Suppose that money doesn't matter. Suppose you had all the money and all the talent. What would be your dream research project?
Yeah, it's a very good question. Actually, yeah, the dream. I think we should, training the complex model maybe in 1 week. So, for example, for GPT-3 right now, our machine will take 1 month.
Mm-hmm.
Maybe GPT-4 may take longer. So we think maybe some model even maybe 100 times complex than GPT-3. Then we still down in 1 week. So that's one research topic we are going right now.
I mean, I guess eventually we'll be there. According to Moore's law, things will always get better. So when do you think we'll be in 1 week for? Would you be able to do this in 1 week? In 2 years' time or in 3 years' time?
Or maybe our plan actually is 4 year time.
4 year time. Okay, good. We'll talk again in 4 years. Okay. All right. Thanks very much for this very inspiring talk. Great to have you as a speaker today. Good. So we are moving to our next speaker. And I'm happy now to welcome Mr. Wang Xinhui. He's the General Manager of Standardization and Industrial Relations and in charge of technology innovation, standardization, strategy, and industrial relations building. And he is the Vice President of ZTE Corporation. So Mr. Wang is a standards pro. And he has been focusing on advanced radio access technology research and standardization, and he has over 50 granted patents held globally. The ZTE team that he supervises works in over 100 international, regional, or domestic standardization organizations or industry consortia, fora, and open source community. That's an interesting number. A company like ZTE needs to be active in over 100 standards organizations. That's very impressive. So just to mention one of Mr. Wang's leadership roles in standardization, he's active in 3GPP, the umbrella organization that develops mobile standards, and he was vice chair of one of their technical specification groups for many years. So I'm very happy to have Mr. Wang today with us. And the floor is yours, Mr. Wang, please.
Thank you, Richard. Good morning and good afternoon, good evening, ladies and gentlemen, distinguished guests. First of all, I would like to thank ITU for bringing us this great event of AI for Good, which offers us the really vital opportunity to talk with people, share with people the power of good technology and the power of good practice. It's very good. You know, AI for Good has been held for 4 consecutive times, as just you mentioned, I would say since 2017, if I remember correctly. And we are very pleased to see the rapidly increasing scale and influence of this activity. And the 3 major goals of the AI for Good in my mind, which are identify practical application of AI, scale solutions for global impact, and accelerate progress towards the United Nations Sustainable Development Goals, essentially inspired the whole industry. We are indeed honored to work with ITUT and ITUR and ITUD, the whole ITU community, and other partners to make this fifth a better one. I want to share you with, share all of you with something which in my mind is living on what is happening right now and what's going to be done in the future. Next one, I'm going to show you some. Sorry, I want to check my. I'm not sure if this one works or not. Okay, it's good. And then this one basically consists of the whole outline, whole skeleton of my speech. I want to start with some trend and then give you some examples and practices of our present cases, and then we're looking for some future with some imagination. Let's dive in on the trends. But you can see, okay, historically, there are 3 waves of AI over the past. The first wave is pretty much in the 50s, and then second wave is in the 70s. I don't want to go through this in detail today. We're pretty much meeting the third wave of AI, which is highlight with the deep learning technology. I tend to, I would say, group this third wave into 3 different categories or 3 different phases. The phase 1, I would say, it's a sprouting phase, starting from 2006 to 2012. In this phase, classical machine learning was in mainstream, and the success of the SVM, which stands for support vector machine, and boosting algorithms was the culmination of the classical machine learning research based on some human designated features. But however, even this SVM something can perform very well in classifying data with quite a complex distribution. But the sad thing is, it cannot even distinguish this, as you can see on screen, the little lovely, adorable cat. It completely has no idea, is this a cat or just a piece of cake? So with this, and then the deep learning began to sprout. And in the second phase, which is a maturing phase, starting from 2012 to 2016. In this phase, one thing called AlexNet turned out to prove the effectiveness of this deep learning algorithms in feature extraction and something else. And I think then people have witnessed a great breakthrough in voice and the visual recognition with a accuracy rate of 99% and 95% respectively. In addition to this one, the GAN, which stands for this generative adversarial network and adversarial attack, have been proposed to generate new data with the same statistics as the training set. And the last stage, I would say, it's pretty much it was started from 2016 to now. The main, I would say, characteristics of this one is astonishing performance of AlphaGo really drew the attention of the whole world, and then really drove the renaissance of the reinforcement learning. At the same time, the basic ability of vision, learning, and speaking based on some deep learning algorithms are becoming mature enough and ready to commercialize. So in this period, not only AI algorithms can make some good progress, and the rapid development of the other technologies, for instance, the chipsets, the 5G, the Internet of Things, and some other things, promising technologies, also jointly facilitate this further development of the AI technology. For instance, autonomous driving, everybody knows. So at this stage, we can see that the wave of AI is still spreading, and the potential of AI is out there for us to explore. With this understanding, we go to the next one. Some trends, I would say, it represents the direction we're going to look at in the future. We can see pretty much four trends. The first one is, I would say, from industry point of view, we would like to see a more and more integrated things, like AI can be integrated to retailing, to finance, to manufacturing, to smart city, healthcare, whatever. You know, a wide variety of companies have been recognized that AI is critical to unlocking new growth opportunities and boosting the industry upgrade and revolution. Without AI, you may not able to do some business from day one. So, in regarding of this technology research, some guys tend to go deeper and dive into details in some well-known areas. For instance, some mature theory research have been put into practice, and there's always high demand for foundation and transformative work that will lead us to a new innovation. For instance, automatic machine learning, adversarial learning, and self-supervised learning are becoming the new topics of this. And in addition to the 2 points I just mentioned, as for the practical application, the ultimate goal of the application is to enable a closed loop control without human intervention. For the workflow of data processing, we aim for a closed loop of perception, transmission, storage, decision making, and action. And in order to apply AI technology, a closed loop of perception, learning, and deployment is definitely desired. The last one, but not least, a trust AI can be a key issue in our AI practice. Trustable. It needs to be trustable. We need to deal with the risks of AI deployment, like poisoning, adversarial, invasion attacks during training or inference states. And additional attention shall be paid to privacy and ethics when feed the data of people to AI algorithms. That exactly reflects the theme of this event: AI for good, not for bad. This is something really in our mind. With this, I've been doing something on the trends and on the history of this one, and then I will dive into something happened right now. As you can see on screen, this is it's my overall picture of how AI is doing, what AI can benefit us for the time being. In summary, AI can shape today's society. AI is an application technology. As you can see on the slide, AI theoretically does two things. One is the ability to interact with people, face recognition, natural language understanding, knowledge mapping, personalized some recommendation, web page sorting, etc. These technologies have been there for considerably long period of time. The other one is the expert system. It changes social productivity. And then if you can do this, consequently, it can change production relations, and then societal structure, social composition, so as to complete the change of the business and society. This is what we call reshaping the industry. And next, I will go through 3 different cases plus some practice to show what AI is really doing something for us. It's good. So the first one, healthcare. Everybody knows it. Ensuring good and affordable healthcare for everyone is essential to the sustainable development goal of the whole world for every country. But however, traditional healthcare is facing several challenges. It's quite clear. AI is considering as a promising technology to expand the healthcare services and tackle the challenges. It's transforming, reactive and universal traditional healthcare to a preventive, proactive, and personalized healthcare. AI-based healthcare can be used to achieve intelligent healthcare in various scenarios. Just example, COVID-19. COVID-19 continues to spread around the world. We have alpha strain, we have beta strain, now we have delta variant. No one likes it. No one likes it. But how can we do something with this, I would say, contemporary technology to deal with this, I would say, crisis of this human history? Just example, doing some, I would say, contact tracing with authorized trajectory data. With all this one, be transferred to a platform which is AI assisted, and then this one can do some process and to have a contact tracing map and some contact tracing data be ready on screen in just a blinking of an eye. The efficiency was improved very rapidly, and there are still other scenarios where AI-based healthcare can be used. For instance, in the event of disease, earthquake, or tsunami, or whatever, you can report their authorized location information and monitor information. For instance, my heart rate, my pulse, and to a AI-based processing platform to call for some timely medical resource to save life. In case of sudden outbreaks of disasters, fires, earthquakes, AI still can do the same thing for people. So normally, this is some a general idea and some examples on how can AI do something for our health. Next one is doing something for industry. This is an example of how we can apply AI in the industry part. We just take example of the ZTE's factory in Nanjing. Nanjing is a city of Jiangsu province. When I say me, I mean ZTE. We managed to deploy the latest 5G for this area, and then we put AI on top of this 5G network, on top of all this, the essential equipments in that factory. And this park is equipped with some of the most advanced technology. I just want to give you two examples. The first one is the cloud AGV. AGV stands for automatic ground vehicle, okay, which can convey some goods, some components from place one to place two in this factory. And with this AI assisted power, this AGV can automatically realize how many other AGVs are around them, how far they are, how close they are. And then they can automatically plan I would say, most efficient way to deliver the goods they're going to deliver. This is one example. Second one is, I would say, it's quite typical use cases for AI be deployed in a modern factory, which is called machine vision based quality inspection. You have a high resolution camera on your stream, on your assembly stream, and then you put every picture you put a lot of pictures, depends on your solution. You put pictures for these components on this assembly stream, and then you just upload this rapidly to this, to a cloud. I would say it's a local cloud, and this cloud embodied with some AI technology. This AI technology, also this AI engine, takes some picture you just took and compare this with this exam picture in the database, and then it can have some very fast calculation and knows the result and see, is this one good or not good? If it's good, next stage. If it's not good, throw away. So this is quite typical model and typical idea of this AI assisted machine learning for quality inspection. But to us, it's not a dream. It's not something in the paper. It's reality. We've been doing this. We've been doing this for our 5G base stations. So this is next example. And the last example is about this environment protection. That's always 100% true. We have only one Earth. We got to do environment protection. There's no reason to prevent us from doing something good to protect this blue planet. That's for sure. Here's an example. How AI can possibly be used for environment protection. Typically, there's some on-site, IoT devices, some sensor, keeping tracking of the real-time environment data. For instance, the air pollution level, the water quality, floods, pollution sources, some chemicals, and with some high definition images. All these data can be transported to an AI assisted smart platform through some communication channel. I would say possibly 5G infrastructure. Okay, and then when this AI platform got this, it goes some analysis to make decision in a timely manner with multiple algorithm model with multiple dimensional data, with multiple data confusion, I would say, attempts, and doing some trend analysis. And then it can eventually give you some advice, give you some suggestion from AI point of view in a very, very rapid speed. A good practice is that some scientists in Singapore, that guy, they use this machine learning algorithm to replace human to doing some map reading things. The result was shown that the efficiency can be improved at least by 100 times than what is human being doing. So this is the third example I want to share with you. And all of these fancy functionalities, this healthcare, this factory, this environment protection, need to be backed up with swift, reliability, and intelligent underlying network, preferably wireless network, let's say 5G currently, okay? This is why the demand that network requires more intelligence. As you can see, the one in the middle, the one highlighted in I would say light green, autonomous. Autonomous, for instance, let's just take network optimization as an example. In the past, tasks such as network monitoring, abnormal detection, optimization, all these has to be done by human being. But with this AI assisted autonomous features, the network can do some self-healing, self-organizing, and even some intelligent self-O and M. I would say it's a huge step forward to cut down the cost of human resource. And the next is predictive. It's quite understandable. We can do something much better in terms of optimizing the performance of the entire network if the instant and intelligent traffic prediction is achievable. That's for sure. And then next one, on demand. On demand, I would say, refers to a system and resource in a normal way at some point of time, but it can be automatically increased or decreased upon the latest status quo of the needs. This is also a part of the features which AI-assisted intelligent network needs to be done. The last one, smart operation, is quite self-explanatory. I just want to simply skip this. And then we go to the next page. This is some very good practice in terms of standardization in this global community. Over the past, the global industries, institutions, and academia have been working very closely and effectively to make these aforementioned cases reality by setting up some standards, by forming some open source codes and other collaborations. This is an example which happened in ITUT study group 13. Actually, I would say this group really did an extraordinarily good job on 5G machine learning, reference architecture, and a pipeline, which has been considered the basis of network intelligence in ITUT. And I do believe this, this basic reference will be adopted by the other SDOs in the future. Now, for instance, there's a company I'm working for, ZTE, is no doubt one of the most prominent players on it. We set up a lot of work items, I would say 5, give or take, and proposed a couple of new models and contributed a lot to make this a good example of the ITUT standardization job. And next one is on this open source field. In this open source community, just like the previous speaker, Mr. Gowan, he just mentioned a lot of competition, a lot of capability on this open source. Yes, open source is a part of this AI culture in the world. So without open source assistance, we don't believe AI can be deployed, AI can be absorbed really smoothly and fast. So this is just an example. The ADLIC, it's a part of the XPRIZE Foundation, AI and Data Foundation. ADLIC normally is a toolkit for accelerating deep learning inference on specific hardware. It integrates several well-adapted inference frameworks and can help the users to find the optimal parameters for model deployment so that the deep learning models can be deployed to various platforms with more flexibility and a much faster efficiency. So after being deployed, these models can be able to run automatically and with efficiency and with, I would say, with the performance people are actually expecting. This is just an example of this. I believe other open source communities, they are other than Adlink, are doing something very, very, very good for AI as well. So next, I want to bring you some practice. This is real practice. You know, I'm not intended to do some commercial, but this is quite a good practice I want to share with all of you. Okay, this is called self-evolution network. This is a real product. If you want to buy, pay me, we can sell you. This is self-evolution network solution based on this AI philosophy. We do this with some different level of capability. We have interdomain level of intelligence. AI capability is intrinsic in this network, which means AI capability was designed at the very beginning of doing this system. This is a good example. We just introduced some code, open source code, just like I mentioned, add a link into it, and we just refer to the very good I would say AI open source infrastructure, which has been done in ITU SG13 by doing this, by making this a reality. So this is an example. And next, I want to show you. Looks like I'm running out of my time. I just want to go quickly. Okay, it's good. Oh, this is pretty much the last page. Thinking about something in the future, framing the future of AI. What will happen in the future? Clearly, burst of data sources, quick upgrade of computing power, and the AI algorithm are driving AI into the next stage, where AI can be able to learn and evolve by itself continuously. You know, we will see how AI can reshape our life, but in areas like traveling, healthcare, manufacturing. These are algorithms. But if we think a little bit more far away, you know, ultimately, what can AI be capable of? As you can show on the slide, the future of AI could be robotics, could keep us safer from disasters. Yeah, they're smart enough to do us some favor. And AI can give us more time to be creative. We don't have to do some housekeeping. We don't have to cook. They can do everything for us. We just stay there saying, I want a piece of cake, medium cook, that's it. Okay, yeah, looks quite fantastic. But if you know, some bad thing will happen in the future, for instance, just like people have been seeing in some science fiction movies a lot of times, with all these robotic machines, we may not able to have enough job opportunities for human beings. And in the worst case, even worse, where people have technology to transform ourselves to a cyborg, which is like half man, half machine, combine things. In this case, I would say some AI ethics needs to be really studied to prevent, you know, something really bad happen, but keeping the philosophy, AI for good, forever. So this is pretty much, you know, our understanding, our practice, and our envision on the future of AI. And with this, it brings me to the end of my presentation. Thank you for your patience. Thanks.
Thank you very much, Mr. Wang, and for this nicely structured presentation. I would like to ask you questions right on this last slide here. Your futures. Can you show your the last slide?
Oh, sure. Okay, I'm working on this. Hold on. 1 second. I'm doing this. The last one?
Yeah, the future outlook.
Okay, it's here.
Right. Can you make it big? Yeah, good. Okay. So you, or maybe ZTE, seems like a pretty optimistic outlook with respect to what AI will be able to do for humankind. I mean, some people are very pessimistic. They think that AI will destroy humankind, perhaps. So regarding the last bullet point, the sad part is robots will take away most of our jobs. What about the job of people active in standardization? So ZTE is active, in over 100 standards organizations, and other companies of your size are active in a similar number of standards organizations. How will machine learning affect the standardization process? So I'm not talking now about the use of machine learning in the network. I'm thinking about how machine learning will be used in the process of standardization. Will machine learning make the job of engineers who are active in standardization superfluous at one point? Will their jobs also be taken away? How do you have an opinion on that?
Oh, thank you for this quite interesting question. As a guy who has been working in this global standardization community for almost 2 decades, I personally don't like this anticipation. Okay, some fresh guy who was equipped with this AI power, for instance, machine learning or deep learning, in some chip in his mind with some brain-machine interface, and then this guy can easily take over all the things we've done over the past. No, I'm not a big fan of this story. Actually, over the 2 decades working in this global standardization, I would say the standardization job is pretty much creative and competitive. So before the whole world, I mean the human being, are able to advance our AI technology to a pretty high level, which makes AI chipset or AI machine as smart as people, as aggressive as people, as moderate as people. Before that day happens, I'm pretty sure our job as standardization engineer is quite safe. It's quite safe. But okay, on the other hand of this coin is, I don't want that to happen. But there's still some job, some work of this AI in of standardization in a couple organizations around the world. For instance, ITUD, I just said ITUT SG study group 13. They're doing extraordinary good job on this architecture, the framework, the pipeline of AI. And some organizations other than ITUT, for instance, 3PP at CCSA, they're still looking at something to specify even a detailed normatives for this AI. In this case, I would say the standardization engineers are doing some good by introducing AI to a conventional, traditional device, equipment, aiming to facilitate the people, facilitate the whole industry, but nothing else. We don't want to facilitate AI to replace ourselves. This is definitely not the thing. Thank you.
Okay, I'll take one question from the audience. So AdLake, is that available in the automatic factory?
Sorry, what was the question? I didn't get that point.
AdLake, your source.
AdLake, okay.
AdLake, yeah, open source program that you mentioned, tool. Is that available for use in the automatic factory?
I would say it really depends. It really depends, Actually, we have a product, we call this ZTE smart network. We made it and we deploy this in our factory, and that system used some part of this AdLake, that's for sure. But it's not just a copy-paste job.
Okay.
We got this source code and we just do a lot of tailor work. So it really depends on how many resources you want to invest, how good you are knowing this technology. And then if everything is quite optimistic, you can go this way, just like we did. But if things go the opposite, looks like you do need some help from some, a consulting company or some big guys that could be possible or something.
Okay, good. Thanks very much, Mr. Wong, for your talk, and also thank you for saying nice words about the ITU architecture framework, machine learning and communication networks. So now we move to our third speaker.
Thanks.
And I'm very happy to welcome.
Hello, can you hear me?
Yes, Dr. Fong Chin Lan. So Dr. Fong is Chief Scientist of China Mobile Research Institute. And Dr. Fong has led the R&D of China Mobile on artificial intelligence and intelligent operations since 2013. And prior to that, you have been working for over 10 years with AT&T Labs Research as a principal researcher on speech recognition and language understanding and data mining. You also have over 50 US, Chinese, and international patents and about the same number of pending patent applications. You've also won more than 20 domestic and foreign R&D awards, including an AT&T CTO award, and also numerous awards for your AI platform that your team developed, which is called Xintian, which you explained to me means 9 heavens. So I had asked you just earlier why. I know that 8 is a lucky number in Chinese, so I asked why isn't that called 8 heavens, but you explained to me that 9 is also a lucky number. And 8 is more associated with money, but 9 it has higher aspirations. So nice name for this platform. And I'll leave it to you now to, I guess, lead us to the 9th heaven.
Okay, do you see my screen well? Hello.
We see you well, but you need to share your presentation.
Already shared, you don't see my, do you see this shared screen?
I don't see that.
Okay, let me do it again.
So the share button is at the bottom.
Not yet. Not yet.
Not yet.
Okay.
No.
Maybe my colleagues can perhaps jump in and display, but
It should be, let me try. Is it now? No?
Not yet. Sorry.
Okay.
maybe Gino, are you able to display the slides? I'm checking with my colleagues. Perhaps they can put up the slide. Okay, so my colleague Gino is displaying this.
Is it on now?
Right, but it's my colleague sharing.
Or it's my
No, it's your screen. We see it. Yeah, no, it's fine. No, it's fine. Okay, perfect. Yeah.
I'm Junlan and China Mobile. Thank you for the chair to explain our platform 9天. So the talk is AI for 5G and 5G for AI. And I feel honored to be invited to the talk under the big umbrella AI for Good. And I'm assuming this session, the title of the session is AI Empowering Industry Potential. So since China Mobile is the biggest mobile phone carrier or data carrier, so I coming to talk about how we make AI and telecom network, the two work together. So I come up with this team, how to make AI work perfectly for 5G and vice versa. So both 5G and AI, I believe, are game changer for our industry, our future. And by being a hype, you check in the news and it's everywhere. I believe they will change us and they will frame our future in one way or the other. Now, I come up to think how we can compare 5G and AI. And for 5G technology, it's truly large scale. And it's reliable, it's a telecom service. You can rely, once you have a 5G phone or once your factory or a company use 5G, you can rely on this technology. And telecom network is quite complex and it's a huge system. So it's very systematic and easy to deliver. And you can use it, you can have 5G without thinking where that service has been delivered to you, to your device. On the other hand, for AI, it's broader intelligence. So we have the fundamental machine learning, deep learning, reinforcement learning, federated learning, and contrastive learning, continuous learning. There are many frameworks to come up the intelligence. On top of that, fundamental framework is computer vision, speech, natural language processing, dialogue, and recommendation, data analytics. There are many subfields for each of them. So we're benefiting a lot from this broad intelligence, but now we are still kind of in narrow intelligence, which means once we want intelligence, we have to train for a specific task. Now we have lots of pre-trained models to try to go into the general intelligence, but we are not fully there yet. So it's broad, but it's not general. And one nice feature for AI technology is end-to-end. So you don't have to worry about, you don't have to create a pipeline and worry about each step in the pipeline. That's a typical way we design in a complex system. So you only need to, once you have the framework and you worry about your input and your output, you have a clear objective, then you can let AI to train for that objective you design. And it's flexible. And there are also challenges for 5G at this moment, probably 5G plus, 5G plus, and 6G. It's quite complex. Complex means it's lead to high costs to maintain and operate. And it's very dynamic in terms of the user behavior, very dynamic in terms of the wireless technology, and the digital world are quite dynamic. And we have very diverse business needs for 5G. It's hard you have a one network that fits all the needs. Those are the challenges for 5G going further larger scale, further value to be delivered from now where we are. And when we look at AI, we already talked about lots of nice features about AI from the two talks ahead of me. And there are also challenges for it. For example, it's hard to deploy in larger commercial use. And for certain scenarios, it's easy. And it's also high cost to train the model, to have the AI team specialized on a certain part of the AI technology. So the question here is, in order to help each other, is there some synergy between 5G and AI? That's a fundamental question I'm trying to answer in this talk. So my proposal here is they can help each other. For example, you can use 5G to help AI to make AI technology easier to deploy. Because we can easily deliver 5G technology. Can we take the framework of 5G to deliver AI? On the other hand, the 5G and 4G, all the previous generations of network are not flexible enough. And it's a high cost. It relies on lots of human efforts to operate and maintain. What we can take advantage of AI to help the network and this current moment to operate, to ease the difficulty and the complexity to operate a network. And for going forward, AI technology, I believe, will come to each layer of the network to make the network functions, make the core devices in the huge network more intelligent and flexible. So I come to a definition. So what we can do AI for 5G. So we propose a intelligent 5G. So a 5G network, which are empowered by AI technology and systematic integration with AI and the 5G network hardware, software systems, processes to lead us lower cost, high efficiency, and agile businesses. That's trying to come a definition of what is network intelligence, specifically what is intelligent 5G. I give a few examples of intelligent 5G applications. We have deployed over 50 larger scale those applications. I just give a couple examples to get a sense. For example, for operation, we use speech recognition, natural language detection for information extraction, and also lots of classifiers to ping our database of wireless database, core network databases, and transport databases, and pull that out, and also our experiences to run the experiments, and to have an AI-empowered complaint analytics system, which means that once the customer call or email about a specific problem, become a complaint, and automatically take that information and take the key parameters from the text or from the speech, and then they use the knowledge base we build based on the experiences we stored and become a knowledge base. And then we check against all the operation databases and analyze to localize what the problem is and propose the solution. And then it will present the whole solution to the operation person who can further to confirm and solve the problem. It's greatly improved the efficiency. There are many others, for example, voice over IP, quality evaluation, file base station, intelligence check for acceptance. For example, for 5G optimization, trying to optimize dozens of parameters and millions of choices for energy saving, memo optimization, and neighbor optimization. There are many others. There are many applications, intelligent applications for maintenance too. I just give an example to show AI is helping 5G, not potentially, it is now, but we can do way more. So now I talk about how we can push up, we can further extend the potential power of AI in 5G. So I plot this AI for 5G evolution curve. So where we are is the examples I showed to you, I think all like unit intelligence, which means you have one piece of technology and you put it into your system. For example, I can apply a image classification technology to try to recognize all the devices in our base station. That's one piece of technology in one dot. And but in that case, once you want to verify if that's valuable commercially or how that's going to help your customer, it's hard to come up a metric to quantify the value. So then we come to processing intelligence. The example I walk you through the 5G compliant analytics system, which means we connect the AI technology and lots of other engineering in the system, make the whole process intelligent. This is where we're pushing, which means we go from a dot to a line, to one unit intelligence to a process intelligence. Then we come up metrics to measure the intelligence from end to end. And the third level is when we do the AI applications, for each of this application, which it takes a whole team to work on for a couple of months. And once we need to do dozens, thousands of these applications, it's consuming lots of resources of R&D and operation. So we create an intelligent platform, which means we grab the common engineering units, common intelligent computing units into a platform. So the common data processing, common model, and engineering components can be shared in this platform. With this platform, even a non-R&D person who can easily connect the dots and create an application on its own. And further is I'm thinking now, so we do on the IT level, which means you design, you put a software, and in the future, this is where we're pushing is we can do the overall, because the 5G and later on 6G, it's a quite complicated system. How we can make the entire network from end to end to be intelligent. That needs the intelligence needs to work hands to hand, hand with hand, and from cross layers and across different domains. So that's, I'm thinking we are pushing the technology in industries along this line. And that in order to do this, we call for innovations on a few aspects. One is end to end. No matter what we do for the unit level, process level, platform level, or systematic level, we have to come up a metric. We can measure the impact and the contribution of AI end to end. Often the time is we have a piece of technology which is powerful and smart. And once you put it into a very complicated process, the value of the contribution of that piece of technology disappear probably half of the potential. So we have to pay attention to the end-to-end value and contribution. Second is we have many applications and scenarios and chances so we can put AI into 5G. But what's the core theory of our problem, and what algorithms we need to make 5G truly intelligent? So the core algorithms and the core theory, core problems, I'm thinking needs the industries to work with closely with the academia to come up to come to the math to define and to collectively solve the problem. And third one is, although we talk about AI, but AI cannot work on its own. AI has to be integrated with other engineering components nicely, otherwise it won't work. That's why we often say, hey, that's an intelligent system, but once you use it and you kind of feel disappointed, that often the case is we didn't do the optimal integration between AI and other engineering components, which is already but the backbone in our system. And so China Mobile, for this year, we have committed to push our network level, the autonomous network level from where we are about L2 to L4 by 2025. And there we have a white paper to define what does it mean L2? What kind of metrics we define for L3 and L4? The second part is 5G for AI. When 5G was defined by the SDOs, including ITU and other organizations, 3GPP, and we identified three typical scenarios, application scenarios: EMBB, URLC, MMTC, which are true, and we have lots of business needs from these three scenarios. But I'm thinking as something we observe for now when we work in the business as intelligent computing. So over 85% of typical 5G applications for industries are also AI applications. So there's huge overlap in terms of percentage. So which means why a factory wants 5G? Because they want 5G to transfer data quick and faster and reliable enough for the intelligent computing. So I'm thinking intelligent computing and services become another bigger category for 5G services. So given that need, and there are a couple standards which are already working on, not specifically about intelligent computing, but the general computing. For example, ITU in 2019 assume this one CAN, CAN computing aware network was also proposed by China Mobile. And also the third one is by China Telecom and the computing power network. Also, I think it's a Huawei and China Mobile. Maybe I'm not 100% right. But I'm thinking is how to make a 5G work better for computing. And in this computing, I think huge percentage of that computing is intelligent computing. So we have to come to think how to make our network not just transfer data and transfer information. We're transferring data for intelligent computing and services. So I just, this is my last slides. I show how we handle this problem. So we have AI platform, which is called 9AI platform, which have been used support all our applications, internal and intelligent R&D and applications of our customers. So it's the foundation for the intelligent computing inside China Mobile. The second level is how we can grab the resources, which are how we can prepare these resources nicely for intelligence. The data, the intelligence come from three big things, either come from data or come from a environment which can provide feedback, and also come from knowledge. And above that, we set intelligent computing units. We think those are the correct level. We can easily share across our AI capabilities for 5G and also across applications, across layers of the network. So we have the general engineering computing units, feature engineering computing units. We have lots of models. So we wrap the model into model computing units. We have the combined, which you can combine a few models into a computing units. That's the level we share. And the next layer is the AI models and the capabilities. Since this is for 5G and 5G for AI, so we have two kinds of AI models and capabilities. So one being is you have the general ones, which is same as other industries, like natural language processing, speech, computer vision, and data analytics. And then we apply and retrain those models and innovations in those fields into the 5G problems. And on the other hand, we have unique problems when we're trying to solve the 5G intelligence problem. So we come up the 6 type: sensoring, how we can efficiently sense our network, how we can do the control intelligence, and AI also come to strengthen the fundamental sciences of telecom network, how we can do coding, compressing, and the diagnosis, prediction, and decision. We have gone through most processes or key problems into data operation. Those are the ones we think are common. The last layer is the application service. We hope, and now we use this platform and to fasten our process to make 5G AI. And same time, we also pack those services for AI for 5G for AI. So many AI technology providers can share their technology or contribute to solve the core problems, and then make their technology easy to deploy to large scale. And this is also the way we serve our customers. And the testing. So when we do this, so we have to test each piece of the technology, even the resources, like testing the data, environment, knowledge, and this intelligent computing units and all these models. With that, I will stop here. So my personal understanding for AI for goods is we have many AI applications on our mobile phones, our systems. From thinking the AI needs to come deeper to the infrastructure layer versus only staying on the application layer. Once it can help the infrastructure layer, for example, the telecom, it's kind of infrastructure. It's one of the important infrastructure for digital economy. And once this infrastructure has been empowered by AI, I'm thinking the potential good value of AI will be delivered to most people in most comfort way and safe way. This is my talk.
Thank you very much, Dr. Fong, for this very nice talk. I'm always amazed by the scale of operations of China Mobile. I mean, China Mobile has something like 800,000 base stations, and that's just an incredible number that China Mobile is able to manage. My question goes to the opposite scale. So I guess in most or in all countries, it's small and medium enterprises which are the backbone of the economy. You know, for example, in Germany, there are lots of high-tech small and medium enterprises, and they or some of them would like to run their own network. So, you know, what's called private networks or campus networks. And they may, you know, it may be a university or it may be a hospital or it may be some small and medium enterprise, which has maybe 100 or 500 or something like that employees. And they would like to, I think one motivation is for running their own network is trust. They want to be sure that the data stay within their company and they don't want to share it with everyone. So they would like to run their own networks, and they may want to buy or need to buy only like 1 or 2 base stations. Is that a market that China Mobile is also looking at?
Yes, but I think it's come to the enterprise network. The market look quite different between China, Europe, and US. And here we work closely with enterprises to help them to deliver 5G and at the same time keeping their data in their campus under their control. But it's not, we don't see many enterprises come forward to say, hey, we're going to own the network. Because I'm thinking whoever operates a network, it's quite complicated, it's complex, it has come a cost. The cost can only be managed if it's come to a larger scale. Otherwise, it's a cost for the operators. It will be a huge cost for each enterprise, each campus, whoever wants to run their own. It's also, if we separate the market in that way, it's also a challenge to make it safe and secure. But the data concern definitely needs to be addressed. There are many solutions. So we have 3 typical solutions to solve this problem in the market to help enterprises so they can own their data, they can keep their data privately and same times and have 5G working for them. Mm-hmm. So basically it's the control plane are managed by the operator, by us, and they have the data plane.
Okay. Let me conclude with one question from our audience. You had, and I'm going back to your presentation, you had the slide where you show that you will reach level 4 in 2025.
Yes.
And so the total number of layers is 5. So level 5 is sort of like the things run by itself. Do you have any prediction when level 5 would be implemented?
Because standard organizations have a definition of what level 5 means, but each company has their own take. But for now, we don't have a clear target on when and how we can reach level 5. Because the core network technologies are changing rapidly. So that's a huge challenge for network, and probably more challenging problem than level 5 automatic driving of car.
Wow.
So we don't have a clear target. We can reach level 5.
Okay. All right. Thanks very much. And I would like to thank all 3 speakers for the excellent presentation and for the discussion. So with that, we will be concluding. And as I mentioned at the beginning, this was the first of a series of 4 webinars on similar topics. So the next one will be open source, accelerating AI innovation, that will take place on 21 October. Then we have another one called AI in 5G towards a new telecommunication era on 11th of November. And then on the 9th of December, we have Living with AI, Past, Present, and Future. And in addition, our AI for Good platform features almost daily programming. So please check out our program on our AI for Good webpage, and hope to see you next time. Thank you very much. Bye-bye.
Thank you. Bye.
Thank you. Bye-bye.
Thank you. Bye-bye. Nice to talk to you. Thank you.
Yeah, actually, and if I can ask the audience to still fill out whether they liked it, use our net or okay.
Rewind selector. Rewind selector. Rewind selector. Rewind selector. Rewind selector. Rewind selector. selector. Rewind 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 selector.